Myself is Dr. Jitendra Kumar Narwal, Assistant Professor in Chemistry, GMGRR College, Charkhi Dadri. Today we discuss about the topic, the concept of the physical effects, the inductive effect and the electromeric effect. What is the inductive effect? The inductive effect. It is represented by I, and for example, this inorganic molecule, this CH bond. This CH bond is non-polar because the electronegativity of carbon and hydrogen are close to each other. If we replace the hydrogen by highly electron element, that is X, this acquire negative charge, this acquire positive charge, because X have high electronegative as compared to carbon. So this carbon single bond X is polar, and the permanent displacement, of electrons, that is sigma electrons, along the chain of atom due to the presence of polar bond, at the end of chain. This effect is called the inductive effect. It is also called as transmission effect, and this inductive effect decreases from the carbon up to fourth carbon atom तक ये decrease हो जाता है, negligible हो जाता है यहाँ तक, and it is of two types. The minus I effect, that atom or group which have greater electron attracting capacity than hydrogens, they are said to be electron withdrawing group, the minus I effect. And the decreasing order of minus I effect, this NR3, the sulfonic acid, nitro, cyano, fluoro, chloro, bromo, iodo, and so on. And second type is this plus I effect. The plus I effect, that atom or group which have lesser electron attracting capacity than hydrogen are said to be plus I effect. And the electron donating group, alkyl group, are the electron donating group. Among the alkyl group, the decreasing order, tertiary, secondary, primary, methyl or deuterium. And the properties of inductive effect, properties of I effect. It is a permanent effect. It is a permanent effect, and I effect take place in polar covalent bond. And the displacement of sigma electrons. These are the properties of I effect, and in CH bond, that is no inductive effect is possible because electronegative difference between carbon and hydrogen are close to each other. These are the properties of I effect. Next is application of inductive effect. application of application of I effect. The inductive effect plays important role in organic chemistry. The first application is the comparison of relative acidic strength of organic acids. The organic acid also called as carboxylic acids. In aqueous solutions, this carboxylic acid, in aqueous solutions, the carboxylic acid with water exist in dynamic equilibrium, to form this carboxylate anion and this hydronium ion, and the strength of the acid is expressed by Ka. K is acidity constant. This is the concentration of the product divided by concentration of the reactant. The concentration of the carboxylate anion, this is the concentration of carboxylate anion, concentration of hydronium ion, and concentration of this carboxylic acid, and concentration of water is unity because water is taken in excess, so concentration is unity. So Ka is directly proportional to the concentration of the hydronium ion. Any factor that stabilize the carboxylate anion should increase the acidic character. Any factor that destabilize the carboxylate anion, then the parent acid should decrease the acidic characters. For example, the extent of this position of this carboxylic acid and water furnish the carboxylate anion and the hydronium ion depend upon the stability of the reactant related to the stability of the product. And for example, any factors, this is we take the example CH2, CO, O, this one is negative, and कोई group है G is here, group is electron withdrawing group. This is the electron withdrawing group. This group withdraw the electron towards itself, and by dispersing the negative charge and they stabilize the carboxylate anion and increase the acidic characters. If we take the electron donating group CH2, this G here electron donating group, this G electron donating group intensify the negative charge by donating the electrons and destabilize the carboxylate anion and decrease the acidic characters. So in other words, we can say the electron withdrawing group increase the acidic character of the carboxylic acid, and electron donating group decrease the acidic character of the carboxylic acids. If we take the example of the chloroacetic acid and acetic acids, the example, this is the chloroacetic acid and this is acetic acid. This is chloroacetic acid is more acidic than acetic acid because the chlorine behave this electron withdrawing group, and this electron withdrawing group that disperse the charge by this withdraw the electrons and stabilize the carboxylate anion and increase the acidic characters. In this case, this methyl group are electron donating, and this group intensify the negative charge by donating electrons and destabilize the carboxylate anion and decrease the acidic character. That's why chloroacetic acid is stronger than the acetic acid. If we take the example of formic acid, this is the formic acid. The formic acid is stronger than the acetic acid because in acetic acid the methyl group is electron donating group, and this electron donating group intensify the negative charge by donating electrons and destabilize the carbocation. In this case there is no destabilizing effects, so formic acid is stronger than the acetic acid. Second applications, the comparison of basic character of ethylamine, and acetamide, the CS3 CO NH2. This is the acetamide. This is the ethylamine C2H5 NH2, and this is acetamide. And this ethylamine is more basic than acetamide because in ethylamine this ethyl group are electron donating, and this electron donating group around the nitrogen atom increase the electron density around the nitrogen atom. As a result, it is more basic, and in this case the lone pair of electron present on the nitrogen atom is delocalized, or this carbonyl group pi electron shift होंगे toward oxygen, this occur negative charge, this occur positive charge, lone pair यहाँ shift हो जाएंगे, CS3 CO oxygen negative double bond N nitrogen में charge positive, as a result of which the electron density around the nitrogen decreases and decrease the basic character. So ethylamine is more basic than the acetamide. Third is comparison of relative stability of intermediate that carbocation and carbanion. The carbocation is of three types. This is the tertiary carbocation, this is secondary carbocation, this is the primary, and this is methyl carbocation. And on the basis of the inductive effect, this tertiary carbocation is more stable than secondary is more stable than ethyl, and ethyl carbocation is more stable than methyl carbocation, because in tertiary carbocation have three methyl electron donating group. In this case 2 methyl group, in this case 1 methyl group, and more the number of alkyl group, we can say methyl group, attached to this positive charge carbon, more will be the dispersal of charge and more is the stability. That's why tertiary is more stable than secondary is more stable than primary, and primary is more stable than methyl carbocation, and explain on the basis of the inductive effect plus I effect. Next is physical effect is electromeric effect. Next is electromeric effect. It is represented by E, and this effect involves the complete transfer of shared pair of electrons complete transfer of shared pair of electron, that is pi electron, to one of the atom joined by double or triple bond in presence of attacking reagent. For example, this is the carbonyl group. In presence of attacking reagent, this is attacking reagent, and this pi electron आ जाएंगे, and this one negative and this positive, and this effect is temporary and operates instantaneously in presence of the attacking reagents, and this product will revert back to this original electronic structures when the attacking reagent is removed. It is of two types. The plus E effect or minus E effect. The plus effect when the pi electron are transferred towards one of the atom of the multiple bond to which attacking reagent is attached. For example, this is the carbon-carbon double bond, and here HBr. ये पोलर बॉन्ड है, पाई इलेक्ट्रॉन्स के पास जाएंगे, इस चार्ज नेगेटिव, पाई इलेक्ट्रॉन यहाँ अटैक करेंगे and form this is positive, this carbon and this H. उसके बाद Br नेगेटिव अटैक करेगा, this is Br नेगेटिव, ये पॉजिटिव है, and product is formed. And plus effect occurs when the nucleophile attack on the multiple bonds, and minus I effect when the pi electrons are transferred away from the atom of the multiple bonds to which attacking reagent is attached. For example, this is the carbonyl group, and this is cyanide. This is the attacking reagent. Pi electron shift होंगे toward oxygen, this acquire negative charge, this acquire positive charge, and ये यहाँ attack करेगा, and from this Cn and oxygen. The minus I effect occurs when the nucleophile attack on the multiple bonds. This about the electromeric effect. And next question is distinction and difference between the inductive effect and the electromeric effect. The difference between I and E effect, electromeric effect. The I and E. This is inductive effect, this is electromeric effect. First point, it is permanent. It is temporary. It is temporary effect. Second, this displacement of sigma electrons and complete transfer of pi electrons. Third, take place in polar covalent bond. Third point, presence of multiple bond is required. multiple bond is required. Fourth, no attacking reagent is required. Attacking reagent is required. In this case, presence of attacking reagent is required. In this case, it involves the partial separation of charge. Partial separation of charge. In this case, it involves the complete separation of charge. This is all about the differences. और नेक्स्ट जो है वीडियो के लिए अलग जो है टॉपिक डालेंगे कल. थैंक यू.